Hello. So if I asked you for bromine, what is the relative atomic mass? If you look at your periodic table, it might say that the relative atomic mass is 79.9. If it's a bit simpler periodic table, maybe it's GCSE, it might say 80. Now there's something really weird about that. Now do you remember what the relative atomic mass actually means? Okay, the relative atomic mass equals your protons plus neutrons. Now if you look at this 79.9, you'd assume you've got 0.9 of a neutron or 0.9 of a proton there. How is that the case? Well, let's find out. So we know that we've got our proton number. This is the amount of protons that are in each nucleus. Now protons determine what the element actually is. If we were to have 36 protons, that wouldn't be bromine anymore, that would be krypton. So that is the defining thing that makes each element, okay? But your neutrons, they can change. Now you've got two main isotopes, you've got bromine 79 and bromine 81. We've got bromine 79 and bromine 81. Now what does that mean? They both have 35 protons, but they have a different number of neutrons, okay? We can work that out. So we've got our atomic mass, so we're going to do our 79 minus 35, which is our number of protons, which will tell us that we have 44 neutrons. And here we've got 81 minus 35, which is 46 neutrons. So relative atomic mass is a weighted average. Just over half of bromine is in this isotope, and the rest is in this isotope. So scientists, chemists have worked out that actually 79.9 is the average relative atomic mass for bromine. So chlorine here, this is another good example that people use. Chlorine has two main isotopes, chlorine 35, right? And we've got chlorine 37. So the abundance is how much of it exists, okay? Now, for 35.5, well, actually, 75% of it is chlorine 35, and 25% of it is chlorine 37. Those are the two main isotopes, and that is why we have a fractional relative atomic mass on our periodic table. I hope that makes sense. Now, isotopes lead directly into my next topic, where I'm going to be looking at mass spectrometry, which is how we can help identify the different isotopes that are occurring in our sample. Click next or see my website, Chemistry from First Principles. Okay, thank you.